Good morning everyone, good morning. I welcome you all again to the NEET Elite. I hope you guys are doing great, having a good time. Well people, you can let me know in the chat box if I'm audible and visible to everyone, yes. Just let me know in the chat box if I'm audible and visible to everyone. Hello Basit, hi Karthik, hi Chashu, hello Dream Doctor, hi Madhavan, hi Tyag, hello Anbu, hello Bala. Let me know in the chat box. Give me some green signal from the chat box so that I'll get to know whether I'm audible and visible to you guys or not, yeah? Hello Ayush, hi Parneet, hi Agam, hello Ishpreet, hi Oshika, hi Amir, hello Anish. Welcome everyone, welcome back to NEET Elite, yeah? Just give me a second guys. All right, so yeah, I'm doing good. How are you guys doing? I'm doing good, JC Arts. I'm doing good. Perfect, guys. So as you all must be knowing, today it's going to be our, I guess, fifth session from the chapter Atomic Structure. Yeah, and in the today's session, we are going to talk about some important theory about the atom, right? One important atomic model, which is what we call as Bohr's atomic model, okay? Till now, if you remember, we have discussed the Thomson's atomic model, we have discussed the Rutherford's atomic model. Now it is the time to see the Bohr's atomic model, which is one of the most important atomic models right here, okay? Perfect. So people, before starting the session, the ones who are new to the channel, let me introduce myself. My name is Wassim Sir and I'm your chemistry master teacher right here on this NEET Elite channel, yeah? The ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well, and do not forget to hit the bell icon so that you get the notification of every single session which I'll be taking live on this channel, okay? Just let me know in the chat box, am I clearly audible and visible? Yeah? Let me know in the chat box, am I clearly audible and visible? Hello Dhanush, hi Patil. Okay. All right. Basically, I have changed the setup over here, so there might be some noise coming. Yeah. Okay, but I hope it'll be fine for you. Yes, Archita, that's a wonderful book. Perfect, guys. So you can let me know in the chat box if you guys are super duper excited about the session. So this is something which we are going to cover right here: Bohr's atomic model and the formula related to the Bohr's atomic model. Okay, just let me know in the chat box if you guys are super duper excited about the session, yeah? Let me know in the chat box with some thumbs ups. Wonderful, guys. Perfect. All right, so let's get going. Let's get started with something called as Bohr's atomic model, yeah? Okay, I want all of you to note down every single thing which I'll be mentioning right here on the screen, okay? And I'm sure you're ready with your pen and paper. Okay? Thank you, Balwan. Thank you. All right, thank you, Renu. All right, guys, so let's get going with something called as Bohr's atomic model. So first of all, the first point which I would like to share with you, this Bohr's atomic model, it's applicable to the single electron species. This Bohr's model, it's applicable to the single electron species. Point number one, okay? Bohr's model, it's applicable to the single electron species like hydrogen, He positive, Li di positive. Now the point is, what are single electron species, yeah? What are single electron species? Any species which contains just one electron, that's what I'll be calling as the single electron species. For example, if you talk about hydrogen, right? If you talk about hydrogen, its atomic number is 1 over here, right? So this hydrogen will be having one electron in it. I'll be calling this hydrogen as the single electron species. I'll be calling this hydrogen as the single electron species over here. Any species which contains just one electron is what we call a single electron species. Similarly, if I talk about helium, He, okay? If I talk about helium, its atomic number is 2. So basically, there are 2 electrons present in one atom of helium. Absolutely, there are 2 electrons present in one atom of helium, yeah? But people, if I take one electron out from this helium, the same helium, it gets converted into He positive, right? If I take one electron out from helium, it gets converted into He positive, and in this He positive, there is only one electron now. So I'll be calling this He positive as the single electron species again, yeah? Single electron species. Similarly, if I talk about lithium, for example, lithium has got the atomic number of 3. That means in one atom of lithium, there are 3 electrons, okay? If I take 2 electrons out from lithium, it gets converted into Li di positive, and this Li di positive, now it just contains 1 electron, so I'll be calling this Li di positive as single electron species over here, right? So I'm sure you're clear with the fact what are single electron species, okay? Ubaid is asking, sir, what is Bohr? Bro, Bohr is the name of the scientist, okay? Yes. Okay, so this Bohr's model is, first of all, it's applicable to the single electron species. Point number 1. Point number 2. What Thomson said in his model, Bohr told the same thing. What was it? Atom contains equal number of protons and electron, therefore atom is electrically neutral. This is something which Thomson also told, right? Atom contains equal positive and negative charge, due to which the atom is electrically neutral. Bohr said the same thing. The atom, it contains equal number of electrons and protons, therefore the atom will be electrically neutral, okay? Yes. Now people, electrons are revolving around the nucleus in the circular paths of constant radius known as orbits or shells. As per your board is concerned, the electrons, they continuously revolve around the nucleus, right, in some circular orbits, in some circular paths. And those circular paths in which electron moves continuously, they have got the fixed radius, they have got the constant radius, and we call those fixed circular paths with constant radius as the orbits, or you can call them as shells as well, yeah? You can call them either as orbits or shells, right? For example, this is the nucleus, right? This is one of the circular path, okay, in which electron is continuously moving, yeah? This is one more circular path in which electron is moving, one more circular path in which electron is moving, right? So basically, as per your Bohr's model is concerned, the electrons will be continuously revolving around the nucleus in some circular paths, and these circular paths, they have got the fixed radius. They have got the fixed radius, okay? And these circular paths having the fixed radius, the radius of these circular paths, they are not going to change, okay? Yes, and these circular paths having the fixed radius, these are something which I call as orbits or shells, okay? And people, let me tell you, this is, for example, your first shell, and the first shell is called as K shell. The second shell in which the electron can move is called as L shell. Similarly, this is going to be your M shell, and similarly, the other shell which will be after this, that's going to be your N shell over here. So basically, Bohr was the one who gave the concept of the shells, right? Okay, Bohr was the one who gave the concept of the shells, yeah? So remember, from now onwards, electrons, they continuously move around the nucleus in the circular paths, and those circular paths, they have got the fixed radius, okay? And those circular paths having the fixed radius, those are either called as shells or you call them as the orbits, right? This was the next point, okay? Moving on to one more important thing. What is that? See, just look at this statement. The centripetal force required for the circular motion of the electron is provided by the electrostatic force of attraction between the nucleus and the electron. What it means exactly? All of you must have studied something called as centripetal force in your earlier class as well, yeah? Yes, Omar, you can watch it, no issues at all, okay? People, have a look on this statement, it's very important. See, first of all, for any object to move in a circular path, right? Let's say I have got the object right here, and this object is following a circular path, right? The object can only follow the circular path if the object will experience a force which will be directed towards center, and that force which makes the object to move in a circular path, that force which makes this object to follow this circular path, that force is something which I call as centripetal force, right? So centripetal force is the force by means of which the object moves in the circular path, as you all must be knowing, right? Now people, So let me tell you once again what the centripetal force is. Centripetal force is the force experienced by an object by means of which the object moves in a circular path, and the direction of centripetal force is always directed towards the center. Yeah, the direction of the centripetal force is always directed towards the center. The centripetal force will be always towards the center, right? For example, let me tell you once again. Let's say this is the object, and it has to follow this path. It has to follow this circular path, right? When the object was somewhere here, okay, the centripetal force experienced by this object was in this direction. When the object reached here, the centripetal force experienced by this object will be in this direction. When the object will be here, its centripetal force will be in this direction. When the object will be here, the centripetal force experienced by the same object will be in this direction. So remember, centripetal force is always directed towards the center. And what is the magnitude of this centripetal force? Centripetal force is always equal to mv squared divided by r, where m is the mass of the particle, mass of the object which is moving in the circular path, v is the velocity which the object carries, okay, r is the radius of the circular path. Okay, this is something which all of you must be familiar with. Okay, why am I telling you? There is a reason for it. Okay, look here guys, let's say I have got an atom and this is the nucleus of the atom. This is the nucleus of the atom. This is the shell in which the electron is moving, for example. This is the shell in which electron is moving, for example. Yeah, I'm talking about this single electron species right here. This is, for example, a single electron species, and its atomic number is, for example, Z. The atom which I've taken, its atomic number is Z. That means in this atom, how many protons will be there? There will be Z protons in this atom. There will be Z protons in this atom. And all the protons will be inside the nucleus, right? We know the charge carried by one proton is represented by E. The charge carried by one proton is represented by E. Since there are Z protons inside this nucleus, so if I ask you what is the net charge present inside the nucleus, since the charge present on one proton is E, there are Z protons, that means the total charge which will be there inside the nucleus, that's going to be Z multiplied by E. So this is basically, the magnitude is ZE and the sign of this charge is going to be positive. Okay, let me just erase this understood, I believe. Okay, what is ZE? ZE is the charge which is present inside this nucleus, right? Let's assume this is the electron over here, and the electron carries the negative charge. How much charge the electron carries? Electron carries the charge E, right? But its sign will be minus, okay? But the charge will be negative. Magnitude is going to be E, okay? Now people, this is the nucleus carrying positive charge. This is the electron carrying the negative charge. Can I say there will be electrostatic force of attraction between this nucleus and the electron, right? Which will be directed towards the center? Absolutely, yeah. There will be electrostatic force of attraction between this nucleus and this electron over here. And this electrostatic force of attraction, or I can say in simple words, this nucleus, it is going to hold the electron towards it. Okay, this nucleus, it's not going to let go of this electron. Okay, this nucleus is going to hold this electron. This nucleus, this electrostatic force of attraction between the nucleus and the electron, this is basically the cause of centripetal force. Okay, we know, first of all, we know for any particle to move in a circular path, okay, the particle must experience centripetal force, which will be always directed towards the center. At the same time, if I'll ask you what is the cause of that centripetal force which is making this electron to move in a circular path, the cause of that centripetal force is basically the electrostatic force of attraction between the nucleus and the electron. Okay, so basically I must say the necessary centripetal force required for the electron to move in the circular path is provided by electrostatic force of attraction. Let me write it over here in the form of a statement. Okay, let me write it over here in the form of a statement. I'm writing the necessary centripetal force required by the electron to move in a circular path is provided by the electrostatic is provided by the electrostatic force of attraction between the nucleus and the electron, right? Okay, so I can clearly say your centripetal force, which I'm representing by C, it is being provided by the electrostatic force of attraction between the nucleus and the electron, okay? And people, centripetal force, as you all must be knowing, that's equal to mv square divided by r, where m is the mass of electron, v is the velocity with which the electron moves, r is the radius of the circular path. It is equal to electrostatic force of attraction. Electrostatic force of attraction. When I taught you the distance of closest approach, I told you electrostatic force of attraction is basically K ZE square divided by R square. I hope you remember this formula. This is something which I've told you in your distance of closest approach as well, right? As simple as that. Or you can remember it over here as well if you have forgotten. This is the nucleus, right? The atomic number of this atom is Z. So there are basically Z number of protons inside this nucleus. So what is the net charge inside the nucleus? That is Z multiplied by E. What is the charge on this electron? That is E. There will be force of attraction between the nucleus and the electron, and that force of attraction is what I call as electrostatic force of attraction, which is equal to K Q1 Q2 divided by R square. Over here, Q1 is for example ZE, Q2 is for example E. You can put the values, you can get the Fe as K. Instead of Q1, I'll be writing ZE. Instead of Q2, I'll be writing E, so it becomes ZE ka square divided by R square. So basically, this is the formula which you guys are going to remember over here. The necessary centripetal force for the electron to move in a circular path is basically provided by the electrostatic force of attraction between the nucleus and the electron, right? Let me know in the chat box if everything is clear till here. No, Ansha, there is no mentee. I do not take mentees. Hello Rahul, welcome to the channel, bro. Welcome to the channel. Let me know first if everything is clear till here so that I can move on. Shubhankar, there are many formulas in this chapter. I think you have not studied them. I'll be showing you the formulas in some time, okay? Yes, Abhirami, this is an NCRT. Of course, why will I be teaching it then? Of course, Rahul, you can go for it. You'll love it. Perfect. Future aims. That's great. That will definitely help you out. Hello, NEET Motivational. Welcome. Perfect, guys. Let's move on. This was one important statement as per your Bohr's model is concerned, right? Okay. So mv square divided by r is equal to k ZE square divided by r square, right? Now, people, one more important postulate about the Bohr's model. What is it going to be? Have a look. Out of the infinite orbits, electron can only be present in those orbits in which its angular momentum is an integral multiple of h upon 2 pi. What it means exactly? Have a look. What it means exactly. See guys, for example, this is the nucleus of the atom, right? Around the nucleus, there will be infinite shells, there will be infinite orbits as per Bohr, okay? Around this nucleus, there will be infinite shells, infinite orbits, okay, around this nucleus as per Bohr, right? Like this. Now, first thing, let me give you a quick idea about what angular momentum is all about. See guys, let's say this is an object, it has got the mass m, and this object is moving with the velocity v, okay? So this is basically motion in a straight line. This is motion in a straight line. Or you call this motion as the translational motion as well. Let's say the object which I have, it's moving in a straight line. The object has got the mass m, it has got the velocity v, okay? And the object is moving in a straight line. Now people, understand. When the object is showing the translational motion and the object has got some mass, it has got some velocity v, I'm going to define a new term for this object, that's momentum, and momentum is simply the product of mass and velocity, right? Momentum of the object is simply the product of mass and velocity, right? Okay, in physics, you deal it in terms of vector forms, right? I'm not going to deal this in terms of vector forms. Whatever we need over here, that's something which I'll be telling you, right? Okay, so when the object having some mass moves with some velocity v, the object carries momentum, linear momentum p over here, which is basically the product of mass and velocity, right? Now people, if I'll be having an object which has got some mass, The object has got some velocity v, but the object is moving in a circular path. The object is moving in a circular path. For this object, right now, I'll be defining a new term. I won't be defining linear momentum for this object. I'll be defining angular momentum for this object. And angular momentum is simply the product of m, v and r, where r is the radius of this circular path over here. So angular momentum basically is the product of mvr, and your linear momentum is the product of m and v only, okay? Right? It's basically mv cross r. When you'll study your vectors, there you'll get to know exactly what this angular momentum, what is its direction, everything you are going to talk about, okay? But right now, only one thing I want you guys to remember. What is that? Whenever I'll be having an object carrying some mass, moving with some velocity v, okay, and the radius of the circular path is, for example, r, right? Its angular momentum is simply the product of mass, its velocity, and the radius of the radius of the circle, or the radius of the shell, or the radius of the orbit, you can say. Okay. Now, people, as far as Bohr is concerned, out of all these infinite shells, we have got infinite number of shells around the nucleus, right? Out of all these infinite shells, you'll find electron in only those orbits. You'll find electrons in only those orbits in which the angular momentum will be the integral multiple of h upon 2 pi. In which the angular momentum will be the integral multiple of h upon 2 pi. Integral multiple of h upon 2 pi means angular momentum can be h upon 2 pi, it can be 2h upon 2 pi, it can be 3h upon 2 pi, it can be 4h upon 2 pi. This is something which I call as integral. These are something which I call as integral multiples of h upon 2 pi, right? These are something which I call as integral multiples of h upon 2 pi. Or in general, I can say you can find, as per Bohr, you can find electron in only those orbits in which the angular momentum represented by mvr is basically the integral multiple of h upon 2 pi. Okay, so basically, have a look. This is, for example, your shell number 1, right? This is shell number 1. For this shell, n is equal to 1. This is shell number 2. This is shell number 3. This is shell number 4, right? You can see. If I ask you what is the angular momentum of electron in this shell, it is going to be what? It's going to be nh upon 2 pi, since n value is 1, so h upon 2 pi. Right here, what is the angular momentum of an electron moving in the second shell? Put the value of n as 2, it's going to be 2h upon 2 pi, right? Similarly, over here it's going to be 3h upon 2 pi, it's going to be 4h upon 2 pi, right? It's going to be 5h upon 2 pi, absolutely. So basically, around the nucleus, you have got some infinite shells, and out of those infinite shells, you'll find electron only in those shells in which the angular momentum will be the integral multiples of h upon 2 pi over here, right? You cannot see electron in that shell in which the angular momentum will be, for example, 1.1 h upon 2 pi, for example, 5.1 h upon 2 pi, right? No, you cannot find electron in that orbit in which the angular momentum is not the integral multiple of h upon 2 pi, right? You cannot find electron in that orbit in which angular momentum will be 1.1 into h upon 2 pi. You cannot find electron in that orbit in which angular momentum is, for example, 3.3 h upon 2 pi. You can find electrons in only those orbits in which angular momentum will be either h upon 2 pi, or 2h upon 2 pi, or 3h upon 2 pi, or 4h upon 2 pi, and so on, right? Yes, as simple as that, right? Let's move on and talk about few more things. Understand? So basically, this is one important relation which I want you guys to remember. Okay, the angular momentum of an electron is basically the integral multiple of h upon 2 pi. People, I hope you remember, in your Planck's quantum theory, I told you your light radiation consists of photons, right? Photon was the smallest unit, right? Photon, if I talk about photon, it was the packet containing some energy. That's something which I used to call as photon in case of light. Okay, what was the energy associated with one photon? It used to be h nu. If I'll be having 2 photons, what will be the energy associated with 2 photons? It's going to be 2 times h nu. Energy associated with 3 photons, 3 times h nu. So the energy possessed by a single photon is h nu. Energy possessed by 2 photons is 2 times h nu. Energy possessed by 3 photons is 3 times h nu. Can I say over here energy is basically quantized? Energy remains quantized basically, right? Right? The energy of photons is basically the integral multiple of this basic unit h nu over here, right? Now we will understand. this is the smallest value of angular momentum h upon 2 pi, right? Then comes your 2h upon 2 pi, 3h upon 2 pi, again the integral multiples of h upon 2 pi. So again I can say, if I'll call this as the basic unit of angular momentum, right? So this is integral multiple of 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 this. Can I say the angular momentum right here again is remaining quantized? Yes. So you can say one simple thing over here. You can say one simple thing over here. What is that going to be? You can say angular momentum of an electron in an orbit is quantized. The way energy used to remain quantized, in the same way angular momentum of an electron in orbit, it remains quantized, right? Okay, I hope you got the idea of what this quantization is all about. Yes? Let me know in the chat box if it is clear to everyone, so that I can move on. Animesh, the next session will be day after tomorrow. So remember, from now onwards, according to the Bohr, angular momentum of an electron in an orbit remains quantized. It's quantized, yes? Okay? Right? The minimum value of angular momentum will be h upon 2 pi, right? Okay? Then it becomes 2h upon 2 pi, 3h upon 2 pi, and so on. So the angular momentum, it actually remains quantized over here. Yeah? Yes, Rahul, you can do that. Perfect, guys. Now one more thing. What was the Rutherford's drawback? What was the Rutherford's drawback? What was it? Rutherford could not explain. See, as per your Maxwell's theory is concerned, what Maxwell said when a charged particle undergoes acceleration, it should continuously emit energy, right? Whenever the charged particle undergoes acceleration, let's say this is the electron is absolutely the charged particle, and the electron, its velocity every time is changing, right? I mean the direction of its velocity every time is changing, correct? The direction of velocity every time it's changing, yeah? So basically, this electron, this charged particle right here undergoes acceleration, and as per the Maxwell's theory is concerned, whenever the charged particle undergoes acceleration, it should continuously emit energy. Therefore, the radius of the path should continuously decrease and electron should eventually fall into the nucleus, right? This was one of the drawback of the Rutherford's model. He could not explain this. But as per Bohr's theory is concerned, what he said was, an electron when revolving in an orbit, when the electron revolves in an orbit, right? When the electron revolves in the orbit, it neither loses energy nor it gains energy. This is something which will be proving after some time mathematically, okay? Whenever the electron moves in an orbit, it neither gains energy nor it loses energy, right? If the electron neither is gaining energy nor is losing energy, then the radius of its orbit should not decrease and the electron will not fall into the nucleus, right? This is something which I'll be showing you mathematically in some time, why electron, it's not losing and gaining energy when it's revolving around the nucleus, okay? So remember, this is one of the important statements as per Bohr's theory is concerned. An electron, when it revolves in the orbit, okay, when it moves in the orbit, it neither emits energy nor it absorbs energy, right? If the electron is neither emitting energy nor absorbing energy, I'll say the energy of the electron in a particular shell, that remains fixed. That's why these orbits are what we call as stationary orbits, right? The energy of these stationary orbits is not going to change at all, right? That's why we call these orbits as stationary orbits. So read it carefully again. An electron, when revolving in an orbit, it neither loses energy nor gains energy, and therefore these orbits are what I call as stationary orbits, right? Okay, I'm sure it's clear to everyone. Let's move on and let's talk about a few interesting things over here, yeah? See, one important statement. Remember, as far as Bohr is concerned, when the electron moves from lower energy shell to higher energy shell, electron absorbs energy. When the electron moves from lower energy shell to higher energy shell, electron absorbs energy. And similarly, when the electron moves from higher energy shell to lower energy shell, electron emits energy. Right? It emits energy. Yes? Okay. Now, understand. Let's say this is the shell number 1 in which electron is, okay? And this electron has to reach to shell number 3. So, electron has to move from lower energy shell to higher energy shell. That means we have to supply some energy to this electron, which I'm supplying in the form of h nu, in the form of light, okay, in order to make sure the electron moves from shell number 1 to shell number 3, lower energy state to higher energy state, lower energy shell to higher energy shell. This electron has to absorb energy, right? And how much energy this electron has to absorb right now? Whatever is going to be the energy gap between these two shells, same amount of energy I have to supply in the form of h nu, in the form of light, then only the electron is going to move from shell number 1 to shell number 3. Okay? Right? Understand it once again. For example, the electron has to move from shell number 1 to shell number 3. So first of all, from low energy shell to higher energy shell, I need to supply some energy. How much energy I need to supply? Whatever will be the difference between these two energy shells, whatever will be the energy gap between these two shells over here, that much of energy I need to provide, then only the electron will make a transition from shell number 1 to shell number 3. So first of all, I have to supply this much of energy, E3 minus E1, where E3 is the energy of the third orbit, E1 is the energy of the first orbit. This much amount of energy, which I'm representing by delta E, this much amount of energy I need to supply, then only electron can move from shell number 1 to shell number 3. And this much amount of energy I'm supplying in the form of h nu. Okay? So basically, by knowing the energy gap delta E, you can calculate the wavelength of the photon. The wavelength of the photon which this electron is absorbing over here, right? By knowing the energy gap, you can calculate the wavelength of the photon which this electron is absorbing right here. Yeah? Right? Okay. Now we will similarly, one more thing. In this case, electron is moving from higher energy state to lower energy state. So energy of the electron will be emitted, right? Okay, how much energy will be emitted? Again, whatever will be the difference, whatever will be the energy gap between shell number 1 and shell number 3, that energy gap, same amount of energy the electron will be emitting when it's moving from shell number 3 to shell number 1. Let's assume energy of the electron in shell number 3 is E3, energy of electron in shell number 1 is E1. The electron has to move from shell number 3 to shell number 1, so it has to emit energy. How much energy? The energy gap. This much energy gap, electron, this much energy gap, okay? Whatever is the energy gap between E1 and E3, between first and third shell, that much of energy electron will be emitting. So delta E, that is the energy gap. Right now it's going to be E1 minus E3, right? Final energy, which is E1 minus E3. Okay, and this much amount of energy the electron will be emitting in the form of what? In the form of photon, okay, where lambda is the wavelength of the emitted photon. So from this relation, you can calculate the wavelength of the photon which is emitted by the electron when it makes a transition from higher energy state to lower energy state, right? Okay, so simple thing. Let me make you understand once again. When the electron moves from lower energy state to higher energy state, electron absorbs energy. How much energy it absorbs? Whatever is the energy gap between those two shells, same amount of energy I need to supply in the form of light, then only electron can move from lower energy state to higher energy state. Similarly, when the electron moves from higher to lower, the energy is emitted. How much energy is emitted? Whatever was the energy gap between those two shells, same amount of energy electron is emitting. Okay? As simple as that. Yeah, this is something which I'll be explaining you in detail when I'll teach you the spectrum. Not now. This is just the quick idea of it, right? Okay. Actual stuff I'll be telling you in spectrum. Okay, right? How to calculate the wavelength of the photon emitted when the electron moves from higher energy state to lower energy state, right? How to calculate the wavelength of the photon absorbed by the electron when the electron moves from lower energy state to higher energy state. Everything will be discussed in detail, yeah, in the spectrum, right? So the energy emitted or absorbed is equal to the energy gap between the two energy shells. As simple as that, yeah? Okay, one more thing I would like to tell you. Let's say this is the nucleus. This is the shell number 1, shell number 2, shell number 3, shell number 4, shell number 5, right? The electron is right now in shell number 1. The energy of the electron right now is E1. The electron has to move to shell number 5. And the energy of electron in shell number 5 is E5. So basically, electron is moving from low energy state to higher energy state. So right now, electron will be absorbing energy, and this energy I'm supplying in the form of light radiations, h nu, right? How much energy I need to supply in order to make sure the electron moves from first to fifth shell? whatever is the energy gap between these two. Energy gap between these two shells is going to be E5 minus E1. This is the energy gap between these two shells, which is represented by delta E, which I'm providing in the form of h nu, or you can say hc divided by lambda absorbed, right? So from this equation, you can calculate the wavelength of the photon which is absorbed by the electron when the electron makes a transition from lower energy state to higher energy state. As simple as that, okay? Understand? Now, for example, the electron is, for example, in shell number 3. The energy possessed by the electron is E3. The electron has to go to shell number 1, and the energy of the electron in shell number 1 is E1. So electron has to make a transition from higher energy state to lower energy state. And we know when electron makes a transition from higher energy state to lower energy state, energy is emitted. How much energy will be emitted by the electron? Whatever will be the difference, whatever will be the energy gap between shell number 1 and shell number 3, same amount of energy the electron is going to emit. Now, if I ask you, what is the difference in the energies over here? Final energy of the electron, which is E1, minus initial energy of the electron, which is E3. This is basically the energy gap between the two shells. And this much amount of energy electron is going to emit in the form of photon hc divided by lambda. This is lambda emitted over here. So by using this relation, you can easily calculate the wavelength of the photon emitted when the electron makes a transition from higher energy state to lower energy state, right? Let me know in the chat box if everything is clear till here so that I can move on to this next thing. Let me know fast. Let me know fast if it is clear to every single guy so that I can move on to something interesting. Yeah? Okay. Guys, there might be some problem in the video. It might be lagging in between. There might be some noise coming because I told you in the beginning, right? I told you in the beginning I have shifted basically from my earlier place to a new place. So the setup is not done completely yet. Okay. So I hope it works. Wassim Pro Subscription classes are in detail, okay? You get everything, material you get in the Pro Subscription classes. Apart from the material, you get the tests, you get the assignments, everything, and you are going to get trained personally by your master teachers, right? For the 2 years, that too, yeah? I'm sure it's clear. Let's move on then. Now let's come to the actual stuff. Let's try to calculate the radius of the nth orbit. For example, I have got the electron moving in, for example, first orbit, second orbit, third orbit. How to calculate the radius of those orbits? How to calculate radius of those orbits, right? How to calculate radius of the first orbit, second orbit, third orbit, fifth orbit, something like that, right? There's a formula for that. How to get that formula, understand how to derive that formula, how to get that formula. You need to remember this, okay? This is important. Understand? See guys, till now, I know two equations. First of all, what I'm going to calculate the radius of Bohr's orbits, okay? I'm going to calculate radius of Bohr's orbits. There are two formulas which I gave you till now. One was mv square divided by r is equal to k ze square divided by r square, right? The necessary centripetal force is being provided by the electrostatic force of attraction between the nucleus and the electron. This is one equation which I gave you till now. Apart from that, I gave you one more equation. The angular momentum of the electron is basically the integral multiple of h upon 2 pi. This is one more formula which I gave you, if you remember. Correct? Now, what do I need to calculate? I need to calculate the radius of the electron in the orbit, right? I need to calculate the radius of the orbits. Radius of first orbit, second orbit, third orbit, and so on. Yeah? So, people, if I look at the second equation, from the second equation, can I eliminate V? V in the second equation is going to be NH, or let me write it over here. See, MVR is equal to NH upon 2 pi. So I can say V is equal to NH upon 2 pi. 2 pi, this is going to be M multiplied by R, right? Let me erase this part. Okay. Now people, understand. If I put the value of V into this equation, what do I get? Understand. So M divided by R, I'm going to write as such. It is V square. V square means this part ka square. V square means N square H square divided by, it's going to be 4 pi square. 4 pi square M square R square, right? I just wrote M by R in the beginning, then instead of V square, I wrote this square is equal to what? This is equal to K Z E square divided by what? Divided by R square. what do I need to calculate exactly? I need to calculate basically the radius of the orbit, right? The radius of the Bohr's orbit. How would I be calculating it? Understand. See what all terms will get cancelled out first of all. Can you see this r square and this r square got cancelled out? This m will get cancelled out with this m square over here. So what I'll be getting radius of the orbit. Just take this r over here and keep all the terms right here, okay? So r is going to be equal. Let me write it. n square h square divided by, it's going to be simply 4 pi square multiplied by, there is 1 m left over here, and from here I'll be getting k, then z, then a square. This is how we calculate the radius of the nth orbit, the radius of the nth Bohr's orbit, right? This is how we calculate actually the radius of the nth Bohr's orbit. Now the point is very simple. What is this n? N represents the shell number. N represents the shell number, right? In which the electron moves, orbit number you must say. And this z represents the atomic number of the atom which I'm talking about, okay? Atomic number of that single electron species, okay? Now we will understand. See, this h is the Planck's constant. It's always a constant, 6.6 into 10 raised power minus 34. 4 is a constant, pi is a constant, mass of electron is constant, k is a constant, right? K is a constant, 1 by 4 pi epsilon naught, if you remember. Okay, and this E is the charge present on electron. This is also constant. So all these terminologies are constant. So I can clearly say radius of nth orbit. Instead of all these constants, I'll be writing one constant, that is r naught. And then in the numerator, I've got n square. And in the denominator, I've got this z over here. Because this n and z, only these two terms are variables over here. Only these two terms are variables over here. Rest everything is constant, right? Okay. Okay, so radius of electron in the nth orbit is equal to r naught n square upon z, and this is something which I'm writing the unit, which is angstroms. This is the formula which you need to remember, and at the same time, this r naught value, you are going to remember it like this, 0.529 angstroms. Okay, r naught value is 0.529 angstroms. Yeah. Okay, as simple as that, right? So people, radius of the nth orbit is equal to r naught n square upon z, where r naught is equal to 0.529 angstroms. Or you can write this formula like this as well now. Radius of electron in the nth orbit is equal to 0.529 n square divided by z, and the units are going to be in angstroms. This is how we calculate the radius of any Bohr's orbit of any atom. Okay, as simple as that. Yes. Right. Now people, one more important thing. I hope you got to know how this formula was calculated. Now guys, understand. From this formula, I can compare the radius of two Bohr's orbits of different atoms. From this formula, I can compare the radius of two Bohr's orbits of different atoms. How come? See, I'll be simply writing the formula R1 divided by R2 is equal to N1 square divided by N2 square multiplied by Z2 divided by Z1. This is one important result which I'll be using directly in the questions whenever I need to compare the radius of two Bohr's orbits of two different atoms. Whenever I need to compare the radius of two Bohr's orbits of two different atoms, okay, I'm going to use this formula, and those atoms should be single electron species. Okay, yes. So remember this. I'll show you its application in some time. Yeah. Now. It's not done yet. It's not done yet. If you look at this formula properly, can I say radius of the nth orbit, it's directly proportional to n square? It's directly proportional to n square and inversely proportional to z, right? Yes. So people, understand few more conclusions over here. More the value of n, as the n increases, n means shell number, as the n increases, what will happen to the radius of orbit? Use your common sense. As the n increases, as the shell number increases, the radius of orbit is going to increase, right? Both are directly proportional. As the z increases, what is z? What is z? As the z increases, radius of orbit decreases. Understand? As the z increases, z means atomic number. Atomic number means number of protons. As the number of protons increase, can I say nuclear charge will increase? As the number of protons increases, nuclear charge increases. And once the nuclear charge increases, electrostatic force of attraction between the nucleus and the electron increases. And if electrostatic force of attraction between the nucleus and electron increases, I'll say the outermost electron will be coming closer, right? So what will be happening to the size? Size will be getting decreased. So, or you can say clearly, radius of the orbit, it is inversely proportional to z. More the value of z, less is going to be the radius of the orbit. As simple as that, yeah? Let me know in the chat box if everything is clear till here. Yes? Okay. Now, this is not done yet. This is not done yet. We have got few more things to talk about. What are those? Have a look. Just a second. Yeah. So, I told you your radius of nth orbit is equal to r naught n square divided by z. Okay. See, this n, it's a variable quantity. This z, it's a variable quantity, right? Okay. First thing, if I'll keep z constant, on keeping the value of z constant, and I need to plot a curve. Between the radius of the nth orbit, and n square. This is the first curve which I'm plotting keeping z constant. The second curve which I'll be plotting keeping z constant, it's going to be radius of nth orbit versus for example n versus n. Okay. What do you think will be the nature of these curves? Simple. See, my basic equation says r radius of nth orbit is equal to r naught n square upon z. So n square upon z, right? I'm plotting radius along y-axis, I'm plotting n square along x-axis. So instead of radius, I'll be writing y. Is equal to, instead of n square, in this equation, I'll be writing x. So this whole becomes slope, which is represented by m. Y is equal to mx means straight line passing through origin. If I ask you the slope of this curve means the value of m, and the value of m is simply equal to r naught divided by z, where r naught is equal to 0.529 and z is the atomic number. Yes, as simple as that, right? The second curve which I'll be plotting, that's going to be Rn, which I'm plotting along y-axis, and n along x-axis. What is my basic equation all about? Again, I'm writing radius of nth orbit is equal to r naught n square divided by z. Since I've kept z constant, right? So, understand, this radius of nth orbit I'm plotting along y-axis, right? This n I'm plotting along x-axis. So instead of n I'll be writing x, but this is n ka square, so x ka square, and this is constant, y is equal to kx square. If you remember, it's going to be parabola opening upwards, right? Yes? Okay. And now people, understand, this is your parabola opening upwards. I've taught these curves in your states of matter, if you remember. Y is equal to mx, y is equal to mx plus c, y is equal to mx minus c, y is equal to minus mx plus c, y is equal to kx square, y is equal to k e raised to power minus 6. All those curves I have taught you in states of matter. Yeah? Okay. These are two important curves which you need to remember. Now people, apart from these two curves, there are two more curves regarding radius which I need to plot over here. First of all, you should know the formula. Radius of the nth orbit is equal to r naught n square upon z angstroms. Okay. Now in the second case, if I keep n square as constant, or let me keep it simple, I'll keep n as constant, that actually means n square is automatically constant. Yeah? Okay. I'm keeping n constant, that actually means n square gets automatically constant. If n square is constant, I'm going to plot a curve, and the curve is between radius of nth orbit versus z, and the next curve is between radius of nth orbit versus what? Radius of nth orbit versus 1 upon z. You can plot these curves as well. These are very important. See, my basic equation says radius of nth orbit is equal to r naught n square upon z. Since n square is constant, I'm plotting radius of nth orbit along y-axis, I'm plotting z along x-axis. So instead of Rn, I'm going to write y, because I'm plotting this term along y-axis. Instead of z, I'm going to write x over here. So can you let me know what is the relation between this y and x? Are these directly proportional or inversely proportional? These are inversely proportional, right? And whenever, if you remember in your states of matter, I have told you, whenever you need to plot a curve between two variables which are inversely proportional to each other, the nature of the curve is rectangular hyperbola, yeah? Okay, Alia, just do one thing, just drag the video a little back, it will be automatically a replay for you, okay? Yes? Rahul, this is something which you can study, because in the NEET 2021 I didn't teach you this chapter, so you can join with these guys, okay? Right? Okay, one more thing. What is going to be the curve between radius of nth orbit and 1 by z? Again, I'm going to write the equation. Radius of nth orbit is equal to r naught multiplied by n square divided by z, or I'll be writing it as 1 by z, right? I'm plotting radius of nth orbit along y-axis, I'm plotting 1 by z along x-axis, yeah? Radius of nth orbit, I can write y, okay, is equal. This 1 by z, instead of 1 by z, I can write x. So instead of 1 by z, I can write x. So this whole term becomes my slope m. Y is equal to mx means straight line passing through origin, and the slope of this curve will be simply equal to r naught multiplied by n square. This is the slope of the curve. Okay, as simple as that. Yes, so these were the formulas regarding the radius of the nth orbit. Now let's come to something called as velocity of the orbits. I mean velocity of electron in a particular orbit. This is something which I told you in detail, right? Okay. Hello Ram, welcome. This is something which I told you. These are the curves which we made. Yes, these are two more curves which we made. Now it is the time to calculate the velocity of the electron in the nth orbit. Yes. Okay. It's time to calculate the velocity of the electron in the nth orbit. How do we do it? Let's get to know. Yes, Sani, I'll be doing that, no issues. I'll talk to my operational team. Yes, Probal, you can do that. Okay, so let's calculate the velocity of the electron in any Bohr's orbit. If you need to calculate the velocity of electron in the first Bohr's orbit of hydrogen atom, how do we calculate it? If you need to calculate the velocity of electron in the fifth Bohr's orbit of hydrogen atom, how to calculate that as well? There's a formula, but let's try to see how that formula comes, yeah? Okay, so we will understand few basic things which I'll be letting you know now. See, first of all, till now, we just know two formulas. One is mv square divided by r is equal to what? Is equal to k ze square divided by r square. This was the formula, right? This was the first formula if you remember. Okay, right? This was the first formula if you remember. The second formula was, let me write it over here. The second formula was mvr is equal to nh upon 2 pi. So people, first thing which I'll be doing, I'll be eliminating radius from here. Radius is going to be nh upon what? nh upon 2 pi mv, right? This is the radius. This is the radius. R is equal to nh upon 2 pi mv. Okay. Now, first of all, one of the r and one of the r will get cancelled out. So, instead of all this, I'll be only writing one r over here. Yeah. So, can I say mv square is equal to k z e square divided by r? Instead of this r, what I'll be writing? Instead of this r, I'll be writing nh divided by 2 pi mv. That 2 pi mv will come to the numerator, 2 pi mv, like this, yeah? So, first thing, this m and m will get cancelled out, yeah? M and m will get cancelled out, one of the v and one of the v gets cancelled out, so you get something as v is equal to k z e square multiplied by 2 pi divided by nh, okay? Now, this is how we actually calculate velocity of the electron in any Bohr's orbit. Point number one. Point number two. If you look at all these terms, out of all these terms, this k is a constant, e is a constant, charged on electron or proton, 2 is a constant, pi is a constant, h is a constant. There are two variables only, this z and n. There are only two variables, this z and n. So, out of all these constants, I'll be writing something like this. Velocity of electron in the nth orbit is going to be equal to, out of all these constants, I'll be writing only one constant, that's V naught, right? Apart from V naught, in the numerator you have got Z divided by, you have got in the denominator as N, okay, right? And this is first of all the formula which I want you guys to remember. And remember at the same time, this formula will be in meter per second if you use the value of V naught as 2.188 into 10 raised power 6 meter per second. Yeah? Okay, so this is the formula by means of which we can calculate the velocity of electron in the nth orbit, right? In the nth orbit. V naught is equal to 2.188 into 10 raised power 6 meter per second, right? If you are using this value of V naught right here, then only you can calculate the velocity of the electron in meter per second. Yes? Yes, there is a beep beep sound. It's not some time bomb sound, okay? It is the inverter battery sound. I hope it's fine, yeah? So this is how we calculate velocity of the nth orbit. Now people, there are few things which you need to take a note of. What are those things? See, velocity of the electron in the nth orbit is equal to V naught Z divided by N, right? Okay, if you look at this formula carefully, as the value of N increases, velocity of electron will decrease, right? As the shell number increases, velocity of electron decreases. Okay, remember this. Similarly, as the value of z increases, you can say velocity of the electron increases, right? These are the two conclusions which you need to take a note of, correct? Yes. For example, let me give you a scenario like this. This is the nucleus, first shell, second shell, third shell, fourth shell, fifth shell, right? The electron is, for example, moving in this shell, and one more electron is moving, the same electron is moving in this shell. Where will be the speed of electron more? Where will be the speed of electron more? Wherever shell number will be less, velocity of electron will be more. So over here, velocity of electron will be more. Over here, velocity of electron will be less. As simple as that. Yeah. Okay. So as the electron comes closer to the nucleus, the speed of the electron with which it moves, that increases. Okay. As the electron goes far from the nucleus, the speed with which the electron moves, that decreases. Yeah. Now people, from this formula, I can basically compare the velocities of two electrons moving in two different orbits. I can use the formula. I'll show you the usage of this formula in some time. V1 divided by V2 is equal to Z1 divided by Z2 multiplied by N2 divided by N1. This is the formula which I'll be using in order to compare the velocities of the electrons, right? This is the formula which I'll be using for the comparison of the velocities of the electrons moving in different orbits. Yeah. Okay. Now, few more things. Let's talk about the basic curves. We got to know velocity of the electron in nth orbit is equal to V naught Z upon N, right? If I keep Z as constant, and I want you guys to plot a curve, between what? I want you guys to plot a curve between velocity of nth orbit versus N. This is the first curve which you'll be plotting. The second curve, keeping the Z constant, the second curve which you'll be plotting, that is velocity of the electron in nth orbit versus 1 upon N. Okay, so simple, you can kill these curves, right? See, velocity of electron in nth orbit I'm plotting along y-axis. This is something which I'm plotting along x-axis. This is something which I'm plotting along y-axis. This is something which I'm plotting along x-axis, right? So in order to make this curve, I should need the basic equation. What is the basic equation? Vn is equal to V naught multiplied by Z by N. So instead of this Vn, in this equation, instead of Vn, since Vn I'm plotting along y-axis, so instead of Vn I'll be writing y. Instead of this N, I'll be writing x. So what is the relation between y and x over here? Are the y and x directly proportional or inversely proportional? Y and x, these are inversely proportional to each other, and we know whenever we need to plot a curve between two variables which are inversely proportional to each other, the nature of the curve is rectangular hyperbola. We know it, yeah? We know it. Yes? Absolutely. Absolutely. Okay, now the second curve, velocity of the electron versus 1 by N. Velocity of electron versus 1 by N. Again, I'll be using the simple formula. Velocity of electron in the nth orbit is equal to what? Is equal to V naught multiplied by Z multiplied by 1 by N. I can write it this way as well, yeah? If Z is constant, I'm plotting Vn along y-axis, I'm plotting 1 by N along x-axis, so this term automatically becomes the slope M. Y is equal to mx means straight line passing through origin, and if I ask you the slope of this curve, slope means the value of M, which is simply going to be V naught multiplied by Z. Yeah? As simple as that. Okay, so this is also done. Let's move on to the third thing, which is something which we call as time period of an electron, right? How to calculate time period of an electron. This is something which I've told you in detail, right? Okay. Time period of an electron. How do we calculate time period of an electron? What is time period of an electron? Simple. It is defined as the time taken by the electron to complete one revolution. Okay, right? To complete one cycle, the time taken by the electron is something which I call as time period, right? Time period of the electron is simply what? It is defined as the time taken by the electron to complete one revolution. Okay? So time period is basically distance covered by the electron. It is basically distance covered by the electron in one complete revolution divided by velocity with which the electron moves, right? Because you know, right? You know, speed is equal to distance by time. So that's how you write it, okay? So first of all, what is the distance covered by the electron in one complete revolution? The distance covered by the electron is going to be 2 pi r divided by. What is the velocity of electron in the nth orbit? It's Vn, right? Okay, I'm assuming the electron is in nth orbit. The radius of the electron in the nth orbit is represented by Rn. The velocity of the electron in the same nth orbit is represented by Rn. Now put the values. It is going to be 2 multiplied by pi. 2 multiplied by pi. Instead of Rn, I'll be writing 0.529 n square divided by z angstroms. But let's convert it into meters. So it's going to be 10 raised power minus 10 meters, right? Divided by. In the denominator, you have got velocity. Velocity, few minutes back, I told you 2.188 into z divided by n, right? 2.188 into 10 raised power 6 multiplied by z divided by n over here. See people, what all terminologies will get cancelled, what all terminologies will be there. See, first of all, this n will go up. It becomes n cube in the numerator, z comes down, it becomes z square in the denominator. So after putting all the values, you'll be getting something as t is equal to 1.5 into 10 raised power minus 16. This is going to be n cube upon z square, right? This is the result which you guys are going to remember, okay? If you divide all these terms over here, at the end, you'll be getting the time period of the electron in any nth orbit is equal to 1.5 into 10 raised power minus 16 n cube upon z square. Only thing, no need to remember this formula. Only thing which you need to remember, that is time period of the electron in the nth orbit. It's directly proportional to n cube and inversely proportional to z square. And from this formula, you can compare the time period of two electrons. From this formula, you can calculate the time period of the electrons in two Bohr's orbits. And how come you'll be comparing them? You'll simply say time period of the electron divided by T2 is equal to N1 cube divided by N2 cube multiplied by Z1 ka square multiplied by Z2 ka square divided by Z1 ka square. This is the formula which I'll be using in order to compare the time period of the electrons moving in two different shells, two different orbits. Yeah? Okay. I'm not going to plot any sort of curve now. Okay. I think this much is enough. And now the last thing, after that I'll show you a few questions by means of which all these formulas will get clear. Now at the end, let's talk about the frequency of the electron. See, frequency is basically inverse of time period, right? Frequency is inverse of time period. We know time period is directly proportional to n cube upon z square, right? Okay, so I can say frequency, it will be directly proportional to z square, inversely proportional to n cube. Only this thing you need to remember. And apart from this, when you need to compare the frequency of the two electrons in two different orbits, you are going to use this formula. Frequency 1 divided by frequency 2 is going to be equal to z1 square divided by z2 square multiplied by n2 ka cube divided by n1 ka cube, right? This is the formula you need to remember in order to compare what? In order to compare the frequency of the electrons in two different energy states, okay? Right? Now people, I think this much is enough. Now it is the time to solve some basic questions from which you will see, you'll get the idea of how these equations are solved, yeah? Okay, so first let me know in the chat box if everything is clear till here. Let me know in the chat box if everything is clear till here or not. Let me know in the chat box with some thumbs ups so that I can move the questions and all the concepts will get cleared, I must say. No twinkle, no idea about the NEET examination yet. Don't go to the false nils. Okay, right? There are a lot of videos on YouTube about the NEET examination. There is no official thing declared as such. Okay. Perfecto. Let's move on. Let's see how this question is to be solved. Calculate the radius ratio of the second orbit of He positive and the third orbit of Be tri positive. So basically, I have got He positive and I have got Be positive. Be tri positive, sorry. Both are single electron species. First of all, if I'll be calling this as 1, let me call this as 2. Let me call this as 1, let me call this as 2. What is the atomic number of helium? That's 2. What is the atomic number of beryllium? Is it beryllium or? Okay, atomic number of beryllium is 4. Hydrogen, helium, lithium, beryllium, right? Okay. Now we will understand. Which orbit am I talking about of the He positive? I'm talking about the second orbit. So N1 is equal to 2. What about the N2? N2 value is 3. What do I need to check? Calculate the radius ratio of the second orbit of He positive and third orbit of Be tri positive. So basically I need to calculate the radius ratio of these two single electron species, R1 divided by R2. Few minutes back I gave you the formula. R1 divided by R2 is equal to what? N square upon Z. So it's going to be N1 square divided by N2 square multiplied by Z2 divided by Z1. This was the formula, I believe. Okay. This was the formula, I believe. N1 square. What is the N1? 2. 2 ka square is 4 multiplied by Z2. What is the value of Z2 over here? Z2 is 4 divided by. What is the value of N1 square? N1 square is 2 ka square 4. Wait, what am I doing? This is not N1, this N2 ka square. N2 ka square means 3 3s are 9 multiplied by Z1 is 2, right? So what do you get? It's 2 1, 2 2. So you get the ratio as 8 divided by 9. So 8 by 9 is the ratio, is the radius ratio of this He positive to that of Be tri positive. Let me know in the chat box if it is clear. Absolutely, it must be clear to you, right? I'll just use the formula. I calculated the radius ratio of these two single electron species over here. Yeah? Okay, let's move on to one more question then. If the velocity of the electron in the first orbit of hydrogen atom is V, what will be the velocity of the electron in third orbit of Li di positive? So basically, I'm giving you two single electron species. One is hydrogen and one is Li di positive, right? Let's call this as 1. Let's call this as 2. First thing, what is the atomic number of hydrogen, which I'm representing by Z1? That's 1. What is the atomic number of lithium? Hydrogen, helium, lithium. That is 3. Okay. Yes. Now people, which orbit am I talking about of this hydrogen? I'm talking about the first orbit, right? First orbit of hydrogen. So N1 is given to me as 1. Which orbit am I talking about in case of Li di positive? I'm talking about the third orbit. So N2 value is 3. Okay. What do I need to calculate? If the velocity of the electron in the first orbit of hydrogen, so basically V1 is equal to V, I need to calculate V2. I need to calculate V2 in terms of V. I need to calculate V2 in terms of V, correct? That's what I need to check. Simple formula, right? What is the formula which I'll be doing, which I'll be using? I'll be writing V1 divided by V2, or let me write V2 divided by V1. No, V1 by V2 only I'll be writing. V1 divided by V2. What was the formula to calculate velocity? V is equal to V naught Z by N. So it's going to be Z1 divided by Z2 multiplied by N2 divided by N1. V1 value is simply equal to V. V2 I need to calculate. Z1 is equal to 1. N2 is equal to 3. Z2 is equal to 3. N1 is equal to 1. Right? So 3 got cancelled. You got the V2 value equal to V. So what does it mean exactly? What does it mean? It means the velocity of the electron in third orbit of Li di positive is same as that of velocity of the electron in the first orbit of hydrogen atom, right? Yes. So this is something which you got. This is something which you got. Velocity of the electron in the third orbit of Li di positive is same as that of velocity of electron in the first orbit of H atom. Yes. As simple as that. So people, this is the question which is going to be your homework, and please do give it a try and let me know the answer of this question in the comment section, right? Okay, let me know the answer of this question in the comment section. So people, I did not finish it yet. In the next session of this atomic structure, we'll be talking about kinetic energy, potential energy, right? Total energy, and we'll be talking about the spectrum as well. Spectrum, one of the most important topics from the chapter. Okay, these two topics will be covered in the next session, and most probably your next session on atomic structure will be see, tomorrow I'm taking a session on chemical kinetics, I guess. So day after tomorrow, after 2 days, I'm going to take one more session from this chapter, from this atomic structure. Okay, so do give it a try and let me know the answer of this question in the comment section, right? So with this, I'll take a leave, but before taking a leave, let me give the quick introduction about the actual long-term courses, okay? The Vedantu Pro Subscription courses. Well, people, if you have not joined in the actual Vedantu Pro Subscription, do get enrolled in the Pro Subscription as soon as possible, right? There are 3 plans which we have. Light program. There are 3 plans: Light plan, Classic plan, and Plus plan, okay? All these plans are basically valid for 2 years. Okay, so these are basically 2-year classroom programs which I'm talking about, okay? And at the same time, what all benefits do I get in this light program? People, there will be live interactive online classes, test series, notes and study material will be given to you, doubt solving during the class, right? And this is the cost of this. You can pay this much of amount in EMI as well, no issues at all. And if you are new to Vedantu, you have no idea of how the actual Vedantu classrooms look like, how the actual paid classrooms look like, how the actual Wave platform, actual Vedantu platform looks like, you can enroll for a month. You can enroll for a month. Vedantu has created an option for that. Just enroll for a month, right? And see if you are getting benefited, then only you can go for the actual classes, okay? Then you can go for the actual 2-year classroom program. You can give it a try for a month. You can take any of these plans, right? And how to take these plans for a month or for the complete package, there's a link in the description box of the video. You need to click on that link. After clicking on the link, you need to use this coupon code WSPRO if you want me to train you personally on your actual Vedantu platform. So do not forget to use this coupon code WSPRO. This is your coupon code by means of which you'll be getting some 10-20% off as well, and I'll be training you personally in your chemistry. Yes? Okay, the question which I gave you, do let me know the answer of that question in the comment section, not here in the chat box, comment section. Okay? So there is one more link in the description box, that's for the Telegram. Do click on the link, get added to the Telegram group and stay updated about the classes. And the ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well. It was nice meeting you today. I'll see you guys tomorrow at the same time. Till then, you guys take care. Bye-bye. God bless you all and love you all. Take care, guys. Bye. Yes, Rahul, they will be doing that.